algebra, we're going to start with the first page now, defining algebraic properties. So these properties listed are true, always true, and they help us solve linear equations, quadratic equations, exponential equations. So we're going to be using these throughout the course, and we just need to know what their names are and what they mean. All right, so property number one, associative property of addition and multiplication. So associate means regroup. We know that order doesn't matter when we're talking about addition or multiplication. So that's basically, we're using the associative property if we're rearranging the order of addition and multiplication. So here's an example. If I have 5 plus 2 plus 1, what if I regroup it into 5 plus 2 plus 1? All right, remember with PEMDAS, we do parentheses first. So we would do the 5 plus 2 first. And I get 7. 7 plus 1 gives me 8. So my answer here is 8. All right, for this next one, I would do this parentheses first. So I would do 2 plus 1 first. And then I would add 5 and 3. So 5 plus 3 is going to give me 8. So I can move the groups around, and it would be the same thing. The same is true for multiplication. So it works for addition and multiplication. Notice the operations that are left out. It doesn't work for subtraction or for division. The order matters there. So go ahead and come up with your own example. It can be addition or multiplication. An example of multiplication would be 5 times 2 times 3, or I can do 5 times 2 times 3. All right, so if we do the 5 plus 2 first, 5 times 2 first, we get 10, and 10 times 3 is 30. Now if we move to the bottom and we do 2 times 3 first, that gives us 6, and 6 times 5 is also 30. So again, we can regroup, it doesn't matter, order doesn't matter with respect to addition and multiplication. All right, go ahead and come up with your own example, something similar to what we did. All right, commutative property of addition and multiplication. So commute means to move the terms around. So it's essentially the same type of thing here. Associate is regrouping. Commute means we're flipping. Order doesn't matter, right? So we could do, let's say, 3 plus 10, or 10 plus 3. 3 plus 10 is 13. 10 plus 3 is 13. If I did multiplication, I could do 10 times 2 or 2 times 10. Both give me 20. All right, so commute means move around. Think of like a commute to work, or like if you've ever heard that term before, a commute is your drive to work. So commute is moving around, right? You're moving the terms around the order. Associate, think of your associates, your group, right? You're going to regroup items into different sets of parentheses. All right. Additive inverses and multiplicative inverses. This is so important for solving linear equations. For every number that exists, there's an inverse or opposite number. So with addition, that opposite number, if we add the two terms together, it gives us 0. So let's say 5 plus my additive inverse would be negative 5. That's the additive inverse to give me 0. So go ahead and think of it your own example. You could say 3 and negative 3. You could say 10 and negative 10. So for every number there exists an opposite number that would, when we add them together, we get 0. All right, for multiplication, it looks a little different. So in multiplication, there exists a number that when we multiply it, we could get 1. That's the multiplicative inverse. So if I have the number 2, I can multiply 2 times 1/2. You go to Desmos because this would show it a little better. All right, 2 times 1 divided by 2, and that gives me 1. So basically the multiplicative inverse is when you make the number into a fraction, you flip that fraction upside down. So for instance, if I gave you the number 5, you turn 5 into a fraction by writing it as 5 over 1. 5 over 1 is the same thing as 5. 5 divided by 1 is equal to 5. So my multiplicative inverse here would be just the reverse of this. 5 over 1 times 1 over 5. Remember, with fractions, you just multiply straight across. So 5 times 1 is 5. 1 times 5 is 5. So you end up getting 5 over 5, which is the same thing as 1. Remember, with additive inverses, we're adding them together to get 0. With multiplicative inverses, we're multiplying them together to get 1. All right, so if I had the fraction 2 over 3, I would just flip it to get the multiplicative inverse, 3 over 2. 2 times 3 is 6. 3 times 2 is 6. So look, we're using commutative property, right? The order doesn't matter. 2 times 3 is 6, and 3 times 2 is 6. They're both going to give me 6, which is the same thing as 1. So tell me, what is the multiplicative inverse of 2 over 7? All right, I hope you said 7 over 2. You just flip it. 2 times 7 is 14, and 7 times 2 is 14. 14 over 14 gives me 1. So go ahead and write your own example now for multiplicative inverse. All right, distributive property we know. We're going to distribute or multiply the term inside by the outside term. So look, if you see A is on the outside here, we're distributing A to both these terms. So it's the same thing as saying A times B and A times C. So we already know how to do distributive property. 2 times x minus 1 is the same thing as saying 2x minus 2, right? If I multiplied both 2 times x and 2 times negative 1. All right. Here's a USA test prep example. All right, it's given that 2 times 3 plus x is equal to 6 plus 2x. All right, so what that's saying is that 2 times 3 plus x is the same thing as 6 plus 2x. We set the equal sign because they're the same exact thing. We distributed the 2 between these two terms, and that gives us 6 plus 2x. So this is an example of distributive property. All right. Let's go ahead and work through these examples of the different properties. So, for example, number 1, 3 times 4z. 3 times 4, basically what we're doing is we're regrouping, right? Regrouping. So we're saying 3 times 4z, we're just multiplying the 3 and the 4 first and saying 12z. So my final answer is 12z, and all we did was regroup, right? Instead of 3 times 4z, we regrouped it into 3 times 4 times z. So it's the same thing as 12z. All right, so let's look at this here. We have 3 plus 3 plus m plus 6 is equal to m plus 6 plus 3. So blank property of addition. All right, so all we did was we changed the order. You see how we put the m plus 6 first and then the 3? So if we're changing the order, remember we're moving things around, that's commutative. We basically got those two properties of addition and multiplication. Associative is regrouping, commutative is moving them around. All right, so we got commutative property of addition. Now we're regrouping. Instead of grouping the m and the 6 together, we're grouping the 6 and the 3 together. So remember, that's associative property. And then are we doing addition or multiplication? This looks like addition. All right. And essentially what we're doing here is something you've done before, combining like terms. Distributive property and combining like terms, right? So now we just regrouped the like terms together, the constants. So 6 plus 3 is going to give me 9. So my simplified answer is m plus 9. So these are things that we already know how to do. We learned them in Unit 1. We're basically just, let me zoom out just a little bit so you can see the whole thing. We're basically just naming the algebraic property that goes with it. All right, next up, let's see if we can get this. So what did we do here? We have g plus 4 plus 2, and then we changed what's in the parentheses, and instead of g plus 4, now we grouped 4 and 2 together. If we're regrouping things, is that associative or commutative? All right, I hope you said associative, like your associates, your group. So associative property of addition. Now, since we've regrouped, all we're really doing is combining the like terms. We regrouped the 4 and the 2 together because they are like terms. All right, so our simplified answer is going to be g plus 6. I got the 6 because I combined the 4 and the 2 together. All right, let's look at this one. 1 plus r plus 3. And all we did was we switched the order around, and we put r plus 3 plus 1. So when we switch the order around like that, that's called commutative property, because commute means to move, right, move around. Commutative property of, and then we're dealing with addition, so we're going to put addition. Why did we have to move it around? Basically, we're moving things around to get the like terms next to each other. You see the 1 was right next to the r. We're switching these around to put the 3 and the 1 near each other because we know they're like terms and we're going to combine them. All right, now we're going to regroup. Instead of grouping the r plus 3 together, we're going to group the like terms together. So when we regroup something, we call that associative. Associative property of addition. We regroup because they're like terms. So now my final answer is r plus 4. 3 plus 1 is 4. All right. Okay, let's see what we did here for number 4. Number 4, we have 2 times 7f. And look, instead of grouping the 7 times the f together, we're going to group the 2 times the 7 together. So if we're regrouping something, is that commutative or associative? All right, I hope you said associative. And this time, what's the operation we're dealing with? Addition or multiplication? Multiplication. So this is associative property of multiplication. We're regrouping, right? So we're going to multiply the 2 times the 7, and we get 14f. So my final answer here is 14f. All right. 4t times 4. Okay, so the first thing we want to do is switch this order around so that we can have the coefficient and the constant next to each other, right? So when we change the order of something, we are calling that commutative property of multiplication. So changing the order is commutative. Regrouping the groups is associative. All right, here is where we're regrouping. Instead of grouping the 4 times the t together, we're grouping the 4 times the 4. So that's going to be associative property of, is this operation multiplication or addition? All right, I hope you said multiplication. All right, so 4 times 4 is 16. So my final answer here is 16t. And again, we already know how to do this. We did this in class. We're just basically putting property names to these. These are algebraic properties, and we're naming why we can do them and how we know to do them. All right, so number 6, 3 plus 2 times c plus 6. All right, so the first thing we did is we dropped these parentheses. You can see that we took the 2 and we distributed it out. So 3 plus 2 times c plus 6. 2 times c is 2c, and 2 times 6 is 12. So we use distributive property to distribute that outside term too. All right, now what did we do here? It looks like we reordered. We moved the 2c in front and then moved the 3 behind it. So we switched the order of these two right here. So remember, when we're moving them around, we call that commutative. Commutative property of addition. All right, now that we got the like terms next to each other, let's go ahead and simplify. That's going to be 2c plus 3 plus 12 is 15. So we just combine the like terms here. All right, only a few more left. Okay, so we have grouped -4 times 6d, and all we're going to do is regroup. Instead of putting the 6 with the d, we're going to do -4 times 6. So when we regroup something, that's associative. All right, so when we simplify, we're going to do -4 times 6, and that's going to give me -24d. All right, we have one term on the outside of parentheses with two terms in it, so you should be thinking distributive property. Distributive property. We're going to distribute the 4 to each of these, and we'll do 4 times 7, -7, and 4 times 3j. So 4 times -7 gives me -28, and 4 times 3j is going to give me plus 12j. So I have -28 plus 12j. All right, 10x minus 2 times 3 plus 5x. Well, the very first thing we need to do is get rid of the parentheses with these two terms in it. So we need to use distributive property. We're going to multiply the -2 times 3, and we're going to multiply the -2 times 5x. All right, so now that we've multiplied everything out, we're going to change the order with commutative property. We're going to put the 10x and the -10x together because they're like terms. And then we grouped them together with the associative property of addition. Now, I know that 10x minus 10x is going to give me 0. They cancel out. And I know they cancel out because they're additive inverses. 10x minus 10x gives me 0. They cancel out. So the only thing I have left is the -6, and -6 plus 0 gives me -6. That's my final answer. My document camera stopped working for that last one, of course. All right, so this last one, it looks like we're canceling out the a's because I have an a on top. And when I say a on top, I mean I can rewrite this as a fraction with a in the numerator. So I have an a on top and then an a on the bottom, one a in the denominator. Those actually cancel out, and when I multiply them together, I end up getting 1. A over a, which is the same thing as 1. So 5 times 1 just gives me 5. So basically those a's cancel out because they're multiplicative inverses. And I can just get rid of them completely. So now I have 5 plus 2. I have two constants. Those are like terms. 5 plus 2 is 7. That is my final answer.